So question 12 is something that I don't think that we're approaching mastery. That's why mastery yet with. That's why I decided to give you these things. And what I'm doing is I'm essentially taking y equals ab to the x power, and I'm using, for example, the x and the y from the first point, and I'm plugging in the x is 1 and the y is 6, and I'm using the x and the y from the second point, plugging in x is 2 and the y is 18 to come up with this system of equations. So that's what I'm doing there, and I gave that to you this time. But if you're told that you're trying to find an equation of this form, y equals ab to the x, this is certainly one thing that you could do. Plug in the xy you have and come up with two equations. Now, the next thing we could do is kind of take a systems of equation approach with this. We probably have to use substitution here, but if I look at this first equation, right, 6 equals ab, right, it's ab to the first, but that's just ab. I can get a alone by dividing both sides by b. So if I'm real clear, what do I have here? This is a giant 1, so I have that a is equivalent to 6 divided by b. What's nice about that is this expression, 6 divided by b, is a great substitution for a in the second equation. So if I make that substitution, I end up with 18 equals 6 over b, and then we're going to multiply that by b squared over 1. And I'm just expressing the fact that b squared is b squared over 1. So if I do a bit of simplification with the right hand side, I've got 6b squared all divided by b. Well, there's a common factor of b in both the numerator and denominator. In fact, if I choose to, I can write that b squared as b times a b, so I can clearly see, yeah, there's a giant 1 there. So that right hand side becomes simply 6b after I simplify it, and the left hand side is 18. And if I divide both sides by 6, we can see that b has to be the number 3. Well, now that I know that b is 3, that's my multiplier, right? If I look back at the original thing here, y equals ab to the x, I know b is 3. I'm multiplying by 3 each time. The question then becomes, well, where's my initial value? Where am I starting at? What's a? Well, if you look at your work, our work, you can see that a, we've got a nice expression for it. A is simply 6 divided by b. So if I plug that in, if I plug in that b is 3, I can see that a has to be 6 divided by 3, or a must be 2. So we end up getting that a is 2, our starting term is 2, or our beginning is 2, or our 0th term is 2. And as we move forward, we're multiplying by 3. So the answer here is y equals a times b. No, I know what a and b are now. Y equals a, which is 2 times 3 to the x power. And it is worthy to go ahead and plug in the x and verify you get the correct y. Plug in this x and verify that you get the correct y. Because this is not a solution to this problem if it doesn't treat these 2 points correctly. Another thing I want to point out at this point is we were lucky here, all the b's canceled, but if you recall, we have done this where we get problems like perhaps maybe b to the 4th power is, I don't know, we could say 16 if we wanted to. And then the question is, well, what's b? Well, in this case, 2 times 2 is 4, times 2 is 8, times 2 is 16. b has to be 2. But if you don't know that, if you recall, we've been using 4th roots. So if we use the 4th root of each side here, we could figure out what b is. And again, on your TI-83 calculators, I believe the key sequence is enter the root, so the 4th root, and then you press the math button, and then you say, I think option number 5. Option number 5 is that it looks like this. I think it looks like the xth root of something. and then you enter the value that you want to take the root of. So you would enter 16. So if you do that, the fourth root of 16, that's how you would enter this on our classroom calculators. It would report that, oh, that base would have to be 2. Then what's nice is you can always check that answer, because if you take 2 and on your calculator you raise it to the 4th power, it better give you the number 16. Anyways, that's not related to this problem at all. I just want to review with you the fact that sometimes when you do these, this might be b to a power equals some number, and that's how we were dealing with that.